Okay, so what we're gonna do is we're gonna try to prove the trig Pythagorean identity, trigonometric Pythagorean identity by using a spreadsheet. Okay, so what we want to do is type in all the formulas that convert a degree to a radian, both visualizing the text as a fraction and as a decimal approximation for those radians. And then take the cosine, the sine, square the cosine, square the sine, add the cosine and the sine, and see how it's always going to equal to 1. Okay, so we're going to start with the gray box has the formulas that we need to type in. So all you got to do is type it in. The first one's 0. Okay, the second one is equals, and I can tap A5 slash 180, right? That's the first one. The second one is equals B5, and that's it. Nothing else. Nothing else. Just B5. Now it did enter additional information in there. Let me see if I can make sure that, yeah, I don't need divide by 180. It's just B5. Whatever that's it. It has some autofill. Make sure that you don't allow it to do that. This one would be B5 times PI parentheses. Okay, this one would be equals to cosine D5. This one would be equals to sine D5. This one would be equals to E5 raised to the second power. This would be equals to F5 raised to the second power. And this would be equals to G5 plus H5. Okay, so now that's equal to 1. So now what we want to do is we want to highlight that yellow strip and then copy, go to edit and copy, and then go to the next several cells if you want to. Let's see, just highlight several cells like this, and then edit and we want to paste special formulas only so that they're not yellow. Okay, now the problem with that is the formulas are correct and they are relative copies, because if you look at the formula here, notice how the very first formula we typed in was A5 divided by 180. The next one is A6, A7, A8. So it copies and it updates the formula to whatever row it's in. Notice how this row is row 15. All the formulas are going to have a 15 in it. So that's called a relative copy. The problem is it's always the same because all the degrees are 0. The next one should be 1, 2, 3, 4, etc. But we're going all the way to 360 degrees. We don't want to type one at a time. So you just want to do equals, the type of formula is the previous box plus 1. And then what you do is you get that formula, which is whoop, let me undo because I accidentally copied something. It was A5 plus 1. And then you copy that one all the way down. You just drag the little marble there. And that's going to be difficult to do it on your iPad. I know that. So you might have to copy, and then you might have to do this. You might have to copy this by doing edit and copy, right? Or tap on and copy, and then just press this and go down here. You don't have to grab the marble because that marble is difficult to get, but you can grab the center of the cell, just tap the center of the cell and then drag, and then paste. And then paste. Again, on your iPad, you would have to tap and then paste, but there it is. That's another alternative way to do it. Grabbing the marble is the easiest way, right? But there it is. And we're up to 44 degrees. At this point, we just want to highlight the last row. Grab the little it's called the handlebar, the little handlebar, the little marble there. Just drag it all the way down to 365. Or copy and paste all the way to 365, and that'll have all the degrees. There we go. That'll be all the way around to 360 degrees. Okay, so now what you want to do is 1 over 30 or pi over 30. We want to highlight that orange. We want to highlight that orange. No, not the text. We want to do a little bucket orange, right? And that's pi over 30. Pi over, and the family of 30s. So the next one, that's not pi over 30. not pi over 30, I'm sorry, that's the wrong one. That's 6 degrees. 30 degrees. Pi over 6. Pi over 6. And again, the little bucket, orange. Pi over 6 and 5 pi over 6, which is 150 degrees. 5 pi over 6. 5 pi over 6 and 7 pi over 6, which is 210 degrees. 7 pi over 6 and 11 pi over 6, which is 330 degrees. 330 degrees, and that's 11 pi over 6. So those are increments, or rather multiples of 30 degrees, right? Or multiples of pi over 6. So you got pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. And there's 4. There's 4 that need to be highlighted orange. And then you also want to do multiples of 60 degrees, or pi over 3. And highlight those like a magenta. So it's 60, 120. Where's 120? 120. And that would be 2 pi over 3. Whoops. Just again. And that's pi over. That would make magenta again. And 120, we see 60, 120, 180, 240. 240. 4 pi over 3. Notice how there's some variation of pi over 3. Right? And the next one would be 5 pi over 3. Right? 5 pi over 3 would be 300. 5 pi over 3. Again, multiples of 30. Or of 60. 60 degrees, I'm sorry. And then, so that, wait. No, that's supposed to be magenta. Magenta. Okay, so the pi over 3 is magenta. Pi over 6 is orange. Now the 45 degree family, which is pi over 4. So that would be 45 degrees, pi over 4, make that a green. And then 45 degrees, 135 degrees is 3 pi over 4, make that green. And then 3 pi over 4, 4 pi over 4, 5 pi over 4 is 225 degrees. 225 degrees, 5 pi over 4. And that would be green. And let's see, 225, 315 would be the next one, right? And I believe that's 4 of them. And then the tangential angles, which are 90, 180, 270, and 360, we're going to make those blue. So 360, 270, those are 3 pi over 2, make those blue. And 180 and 90. So, and those are just the extra connecting to future ideas, where you got the 30, 60, 90, and the 45 degrees, the special triangles. But notice how every single time when you add cosine squared plus sine squared, it's always equal to 1. No matter what degree it is, it's always equal to exactly 1. This is called the Pythagorean trigonometric identity. Okay, and we just kind of proved it using a table of data. This is a lot of evidence supporting that. We're going to